Okay, let's start the next exercise. Exercise 13.2, derivative. Okay, now what is derivative? Derivative, see, derivative is actually slope. Okay, derivative is slope of a line. Okay, now we have learned in our earlier classes, okay, in coordinate geometry and all, if you take a Cartesian plane and you take the x and y axis, and if you take 2 points on the x-axis, say let this be x1 and this be x2, and its corresponding y points are on the y-axis, y1 and y2, and when if you plot the points, and if you plot this the line, if you draw a line joining these 2 points, the slope of this line is calculated by a formula, slope is equal to y2 minus y1 upon x2 minus x1. Okay, this is how we calculate the slope of a line joining 2 points. Okay, now derivative, this is also its slope. Okay, now we'll see if we take another graph, say this is x and y, and if we have a curve, and this, if our graph is a curve, and if there is a point on the curve and a line passing through that point, that single point touching the curve, okay, so the slope of this line passing through this point touching the curve, the slope of this line is calculated using derivative. Okay, here we have, when it is 2 points, we have the difference of y and the difference of x. We have 2 points each, and for x and for y, so we can calculate the slope by dividing its differences. Okay, but here we have only 1 point, so we calculate the slope of such lines passing to 1 point and touching the curve using derivative. Okay, now this line, the line that passes through a single point touching the curve, is also called as tangent line. Okay, now derivative, the notation used for derivative is, now you see this is y2 minus y1, so we can, this is the difference. Okay, so we can write this as difference of y dy. Okay, and this is difference of x upon dx. Okay, difference of y upon difference of x, that is dy by dx. So this is the notation used for derivative. Okay, dy by dx. And there are a few more notations, that is f dash of x is a notation, y dash is a notation. Okay, and there are a few more, but we'll be dealing with this, okay, in our chapters. So now the formula for finding slope is this for a straight line. Now for the formulas for finding derivative, you have 2 formulas. The first one is the basic formula. Okay, that is the first principle of derivative. First principle of derivative. Okay, that is, say example, f of x is a function. Okay, you have some function, then f dash of x is the derivative. Okay, is a notation for its derivative. That is, the formula is f dash of x is limit h tends to 0 f of x plus h minus f of x upon h. Okay, this is the first principle of derivative, the formula for this first principle of derivative. Okay, and the second one, most commonly used, which we'll be, using in the further chapters, all the other remaining chapters. Okay, that is the power rule method. Okay, here the notation most commonly used is dy by dx. Okay, and if say there is a function y is equal to x power n, okay, power n, this is the power rule method, x power n. Okay, so the derivative dy by dx of x power n equal to n x raised to n minus 1. Okay, this is the formula for the power rule method. Okay, now the upcoming chapters will be using this formula. Okay, this is just basic. This formula is derived from this first principle of derivative formula. Okay, now we have a few formulas which should be remembered. Okay, that is dy by dx of x power n. This is the main formula, dy by dx of x power n, the power rule method, that is n x raised to n minus 1. Okay, and dy by dx of 1 upon x is equal to minus 1 by x square. Okay, and dy by dx of a power x is equal to a power x log a. Okay, and dy by dx of e power x, which is e power x. Okay, and dy by dx of log x is equal to 1 by x. Okay, and so on. There are lot many more. And dy by dx of x, okay, is equal to 1. Okay, dy by dx of a constant k is equal to 0. Okay, and okay, that's it for now. We'll see this. Okay, these formulas must be remembered. Now we have few more trigonometric formulas, that is dy by dx of sin x is equal to cos x, dy by dx of cos x is equal to minus sin x. Okay, dy by dx of tan x is equal to secant square x, dy by dx of cot x is equal to minus cosecant square x. Okay, and dy by dx means derivative. Okay, derivative of next is secant x is equal to secant x tan x. Okay, derivative of cosecant x minus cosecant x cot x. Okay, these are the trigonometric formulas, okay, which we often use. Okay, so this must be remembered. And now we have some theorems, that is algebra of derivatives. Okay, algebra of derivatives, that is number one will be derivative of sum of two products. Okay, sum of two functions. Okay, that will be if d by dx of two functions, say f of x plus g of x. Okay, then this can be the derivation can be split between these two, d by dx of f of x plus d by dx of g of x. Okay, next you have the sum of differences. Same thing, if you have if two functions are subtracted, then you can write it as d by dx f of x. If it is d by dx f of x minus e of x whole, derivative, then it can be split into d by d of f of x minus d by dx of g of x. Okay, that is difference of two functions f of x and g of x. Okay, not only two functions, it's more than two, we can split it this way. Okay, now the third one will be product of two functions f of x and g of x. Then that will be d by dx of f of x multiplied by g of x whole derivative. This will be d by dx of f of x multiplied by the second g of x plus first as it is, first function, and derivative of the second function. Okay, this is how it is written. Now this f of x and g of x is made shorter by using a small variables. That is, you can say if f of x is equal to u, and assume f of x to be u and g of x to be v, then you can write this as u multiple u dot v or uv. Okay, and the notation for derivative is uv dash, which I have said already I have said. See, the notations of derivative is, one is this d by dx f dash of x and y dash. Okay, this is also a notation. So that is the notation used here, uv whole dash, that is, it means derivative of f of x and g of x. Okay, so uv whole dash is exactly written in this way, that is u dash derivative of the first expression and second as it is, that is g of x, plus first as it is and derivative of the second one, uv whole dash is equal to u dash v plus uv dash. Okay, this is most commonly used for the product of two functions. Okay, because it's easier writing this smaller version than the bigger one. Okay, the same way you have quotient of two products. Okay, quotient of two products, that is d by dx of f of x upon g of x, okay, is equal to d by dx of f of x, first one, and numerator and denominator as it is, multiplied by g of x minus first as it is, that is numerator, and d by dx of second one, denominator, g of x, whole divided by square of the denominator, g of x whole square. Okay, this also can be written using u and v, that is, if we assume f of x is u and g of x is equal to v, then we can write u by v whole dash equal to u dash v minus u v dash upon v square. Okay, these are the formulas and theorems to be remembered, okay, in solving the problems. Okay, now we will see a few problems.